What's up, everybody? Welcome back. Today we are working on our map that is meant to replace Google Maps Path Planner, so that I can get around the city myself without getting angry at the scheduling of like how Google thinks that I should get places, right? And today's topic is working on adding like a satellite image background to this map. So we started on this yesterday, and we got to the point where we pulled one image from, let's see if we can find it, like Vancouver Ortho Imagery Open Data. So yeah, we pulled it from like one of these, not this one exactly, but one of these. And so the idea here is that satellite images are not actually high resolution enough for us to get street data. What we need is orthographic images from like drones and planes and stuff. And so Vancouver has been nice enough to present us with data that we can use for our map. Other options were a little bit like kind of more license heavy. You could ask Google Maps for its street view data, but then there's like, rules about how you're allowed to use that. You're not allowed to cache the data. You have to be tied to their live service, stuff like that. There's like limits on how many times you can pull their APIs, stuff like that. So the thought is we yoink some data from Vancouver's open data. We like load it into our web app. We maybe like implement some sort of like tiling system so that we can figure out which images to load at which resolutions, and move on from there. So today's task is trying to move on from this, what we have here, to something that's like useful and reasonable. So a plan of action is approximately make it so when we display this stuff like kind of like behind the map. Right now we render it one time on initialization above the map and never again. So we should render it on every render call behind the map, and we should probably render it in the right spot, right? So we have to fix that, and we should probably fix it so that it's right side up. Right, because this is an upside down image. Actually, you guys can't tell that right now, but it is. Display right side up, and we should probably not display it 4 times when we're trying to display it 1 time. So display it right side up and display it right side up /1 time. And then once we have like this one tile kind of displayed where we want it to be, then we can start working on maybe adding some more tiles. I've kind of prepped some more. Not every, I didn't get them all because I didn't run the script for long enough that pre-processed the data for us, but we can probably like start working with a few more and trying to see how they like kind of spread out. Then we should probably work on like level of detail. So these images are too high resolution to display all the time. Probably it probably makes sense for us to kind of have like one image that we display when we're really zoomed out, and then as we zoom in, we like fetch the correct tiles to display in the correct spots. So yeah, we'll kind of see how it goes. We'll see how it goes. We'll see where we get, but that's the plan. That's the plan. So let's start with displaying it right way up and once. So that should be just a simple UV mapping. So what we have right now is we have this like this texture renderer thing, and all we do is we like compile this program using WebGL that has like a rectangle in GLSL land. So if we go to rect GLSL, we just like hard code a quad in here, and then we render it as a triangle strip down here. We say, hey, I want to render the 4 points that are hard coded in you as a pair of triangles. And so it knows to look at like vertexes 1, 2, 3 and 2, 3, 4, and then draw some triangles there. And then it forwards on those coordinates to the fragment shader. And we just have to kind of fix that. So the coordinates forward to the fragment shader are in like -1 to 1 space. But they should be in 0 to 1 for sampling from the texture that we pass in. So here we just have to do a little bit of math. A very small amount of math. So do you render the entire map in shaders? Well, yes, I guess. Everything we render right now, we are rendering in shaders. So all of this data for this like map stuff is like points are uploaded to the GPU, and then lines between those points are uploaded as like an element index buffer. And then we just ask WebGL to draw that shit for us. So here, we just want to make sure that our output thing is verts over 2 to get it from -1 to -1 to 1. This goes -1 to 1 to -0.5 to 0.5. And so then we add 1 after, or add 0.5. And then we have to flip it vertically. So pos.y is equal to 1.0 minus pos.y. And that should get us the correct answer. We should see the image now rendered 1 time right side up. So before, oh fuck, the server's not running, so we can't tell. But that does look like one time right side up. It's a little stretched, but that's okay. And if we compare this to the image that we're trying to render, which I believe is B10, we can XDG open that. And that does look like the same image, right? It's a little stretched, but in terms of like what pixels are making to the screen, I think that we're getting all of the right pixels, just not necessarily in the right spots. So that was actually really easy. That was all of like 2 minutes. Wow, look at us move. Look at us move. Okay, so the next thing I want to do is I want to show it on every render. So right now, the way that this works is in our app, we get this like on initialization, we get this like metadata that's like we call satellite data. It's not really satellite data, but we're calling it satellite data for now. And this is just like an array of tiles essentially. So these tiles are where am I, like what file should you request with like a get call to like get this picture, and what is its width and height in latitude longitude space, and what is its center in latitude longitude space. And so what happens is we fetch that data initially and we ask JavaScript, because this is like a web app. So from our WebAssembly module, we say, hey, JavaScript, could you get that shit for us? And when you get it, could you just like tell us you got it with ID 0? And then eventually he comes back into this like load texture call. I think it's like in index.zig. We have something that's like data fetched with this ID, and we kind of just ignore the ID for now and load the texture. And so this calls render with the texture renderer. We should make it so if we want this being rendered all the time, this should get stashed somewhere. So maybe initially we have like texture is a nullable I32. Yeah, and this starts as null. And then when we load the texture, we use STB image to like get the JPEG data and turn it into a bucket of bytes. Then we like upload that data to the GPU, and then all we have to do is say like self text is equal to text, and then call self render. And then on self render is when we should do bound texture render renders self.text. Surely that will do what I want it to do. Oopsies. Like this. Not quite, because this has to be if self.text text. If we have the texture available, then we render the texture, but otherwise we do not. And really we should render it behind the other stuff, not on top. So maybe we'll kind of do it this way. And we'll kind of see what that looks like. I'm hoping that does what I want. It's possible that that like render call isn't correctly called from everywhere. So it's hard to know why that's not working. So we should try to figure that out. Let's start by saying std debug or std log debug rendering texture now. Let's see if this is getting called ever. Because if this is getting called and we're not seeing what we want, then we've done something terribly, terribly wrong. But I don't know what. I do not know what. He is rendering the texture? Oh, I think this render call clears calls clear underneath the hood, which we don't need to do anymore. If we want, like we shouldn't draw the image and then immediately clear the background. Oh, that's much better. Okay, so there's some problems here for sure. But at the very least, in this case, and maybe on zoom, it's just not on mouse move we're not seeing the right thing. Because I think on mouse move we've bypassed like the normal render call, which is fucking stupid. So we should fix that. We should fix that. On mouse move, he does some stuff, and then he does some rendering based off of the currently planned path. So I think that what I want to do is take all of the stuff that we render here. I think it's fine maybe to continue doing this rendering here for now, because I don't really want to deal with it, but it's just here we should call self render before doing everything else. And I think that kind of fixes it. I think that fixes it. Yeah, there we go. Now, obviously, this is fucking stupid right, to just render one of these tiles onto the whole map. But at the very least, now it's not like disappearing all the time. So now we have like a kind of starting place to work with, where when we move the screen around, we should be able to see it kind of go to the right spot relative to where we're looking and stuff. So that's step 2. Now we have to put it in the right spot. We have to put it in the right spot. So I don't actually know where this thing's supposed to go. We can figure it out. So what do we call? We call load data with satellite metadata 0. Do we stash the satellite metadata? We probably should. So we can kind of put like satellite metadata is a satellite data. Sure. Why not? Why not? And then here we just kind of stash that shit. Metadata. We have to fix the names here. I don't like this thing being called satellite metadata and satellite data, or being related to satellites at all, because in reality we could store like any sort of image tiles in this format. It doesn't have to be satellite related, but you know, it is what it is for now. It is what it is for now, because we need to make progress, not just make superfluous changes for no reason. That's a thing for future me to do off stream or in happy hour. Okay. So now what? We have this information now. What do we do with it? I guess on render, we want to render this thing to like a specific location, right? And so here, we're going to have to support like some sort of movement on this thing. I'm thinking for a second. So there's also the problem where the image space, like our OpenGL world, is working in meters, but the metadata that we have from the satellite metadata is in like latitude, longitude. So we probably have to fix that. But before we do that, let's just kind of like add support in our renderer to kind of just like arbitrarily scale and offset the like what we're drawing. Maybe in screen space, and then we can adjust later. So let's start there. So we'll get into the what do you call this? Image rect.glsl. We have a rectangle, we draw it. And here we just need to say like uniform float xoffs. I guess we should call this like vec2. So like where is the center? And then we also want to figure out like X scale and Y scale. I think that makes sense. So we kind of start with the initial verts, and the initial vertices are centered around 0, 0, and they go from -1 to 1. So we want what? I don't know yet. I guess we apply the scale first. So we'll say like this is like our UV out. So let's kind of call this UV out to make it clear that we're kind of doing 2 separate sets of math for this and this. Then we have vec2 pause is equal to this, and we use pause here, and our pause x times equals x scale, our pause y times equals y scale, and then the center, we just kind of set the center of this to match, because all of this is centered around 0. So all we have to do to get to center is subtract that value. So if the center is at like 1, 1, no, we add the center. So we just say pause plus equals center. And then I think that's it. So these should be maybe we'll call this vec2 scale. And then I don't know how multiplying 2 vectors works in GLSL. Multiply 2 vectors. I don't know what happens. 0.1, 0.4. So it's just component wise. Okay, yeah, that is what I want. So that means I can do pause times equals scale like this. And that should get me what I want. We have never tried to bind a vec2 before. We've only bound float uniforms, but I think that should be pretty easy to fix. We just need a WebGL uniform vec2 somewhere. Hello, MDN? What is the call here to set a uniform? I actually don't remember. GL utils has GL uniform 1F. So it's probably uniform 2F? Yeah. So we are binding 2 floats. What is FV? UI 2FV. Data source offset. Oh, so the V means that it is coming from like memory somewhere, where if we call without the V, we are allowed to just pass the floats as parameters. So what is the U? Okay, UI stands for unsigned integer, I stands for integer, F for float, V for vector. Not all combinations are value. U cannot be combined with F. See the syntax table below. Is there no like uniform 2F? Like you're only allowed to do this for integer ones? What the fuck are you talking about? Gel, Chinese fat gel. I don't know what the fuck you're talking about, but we'll just get you out of there. I don't know. Surely it's not relevant or related to anything. So, bye. It does seem like F does not allow us to use this, which is a little annoying. I'd prefer to use a syntax like this. I would. Unless it's just not telling me that those exist, which would be very pleasant. What the hell was wrong with that guy? Yeah, I don't know. He's confused. Let's just see if we go into index.js. Do I have autocomplete on here? Like this GL dot, no, huh? Okay, you know what? I think that it's not worth trying to like do the pointer manipulation and stuff. So I'm just gonna do this. Float center X, center Y, and float scale X and scale Y. We'll just do this. This is easier. This is easier. So this is scale X, Y. X is center X and Y is Y. Whatever. It's fine. Speaking in tongues. Yeah, that must have been it. Okay, so now in our texture renderer, we are going to look for locations of all of these things. So, I'm gonna kind of put this up here, and then we're gonna add some more names. So, what did we call those things? It was center X. Like this. Then we had Y, and then here we had scale. Center goes to scale. Okay. Which means that here we should be able to like start getting some uniform locations. So center X lock is this. You know what we can do? We can get crazy here. You guys want to see us get crazy? We're going to copy paste these things down here. And we're going to say, start a macro where we find this name field. We delete it. We replace it with location. Right? Then we replace the thing on the other side equals GUI GL get uniform lock from program, and this becomes center X name pointer, and then we can go back, just yank to the end, go back, paste, back a couple words, replace with len, and then end it. We were close. Not a perfect macro, but a close to perfect macro. So here we'll say we go to the end, we go back, we yank to the end, we go to the end, we paste, delete, back a word, len, this. There we go. That was close. That was close. Center x lock is equal to, and then I guess we kind of do the same thing here, where we kind of like yoink this shit, delete everything at the end of the line. We kind of copy paste, and we put a dot here and an equals here, and semicolon at the end of the line. Okay. He also needs all of these things as things that he stores over here. So this is going to be locations as well, and all of these things are just going to be I32s, I guess. So we'll go like this, and we'll go like this, and we'll just kind of do that a few times, I guess. Cool. And now we should be able to say we want to render this thing at some position. So we'll just put center x. I guess, do we just take in all the floats here? Maybe we use the view state? No. Do we have vector types? I think we do. We do have point types and vector types, which are semantically very slightly different. So we'll call this center. Yep, we import this. We call point is equal to lin point, and I guess scale is kind of more like a vector than a point, although it's not really either. Maybe it's kind of, whatever, doesn't fucking matter. Then we set our uniform floats. So we look at the center x lock, center x, center y lock, center y, and center scale. Boom. Boom. Okay. So now when we render this thing, let's just try kind of like having its size. So we'll render it at the center of the screen. So x offset is 0, y offset is 0, and the scale is x 0.5, y 0.5. So it should give us half the size, I think, with pause has static use in Frag Shader, but is undeclared in the verse shader. I think I fucked up. This is no longer pause. This is UV out, I think we called it. I guess the names have to be the same. There we go. So that's better. I think that we have to bring the clear back, because we removed the clear, which makes the background always white, which makes it impossible to see the streets outside the center. So this is function render. We have this stuff, I guess, just kind of comes over here. Let's see. That's much better. All right. Seems like it's kind of working. About the uniform, seems like it looks like you're looking at WebGL rendering context 2. That one doesn't have most of the stuff inherited from the base version. There's uniform 2F and stuff. Oh, fuck. Yeah, that's true. Uniform 2F. Like, is that... Yep. That is nicer. Well, we've already done it, so I'm not going to change it now. But I will maybe write down that I want to change it. Texture render. So let's say GL uniform 2F does exist, and we should use it. There we go. But it's fine for now. Thanks for the help with Too Late. I mean, I'm going to fix it off screen. It's just not worth doing right this second, you know? Okay, so now we can like put a rectangle in an arbitrary spot on the screen. And now the question becomes like, how do we map from like latitude, longitude space to screen space, right? And so, I guess if we follow the pattern of our other renderer, the other renderer is kind of in control of moving things around based off of the current view state. So it kind of makes sense for us to kind of like take this view state and make it accessible to us. And we look at like the center of where we are in the screen and the zoom and the aspect ratio, and we like maybe move these tiles around us according to that. I don't know if it makes sense to do that in our like rectangle renderer. It's kind of like more abstract. You could argue that our like texture renderer is just like an abstract thing that works in screen space. You could argue that. In which case, like having... Sorry, I'm just thinking. So the reason that the other version of our other renderer handles all that stuff automatically is because like the points are defined in the shader. The points are fed in like world space. Where here our rectangle is kind of like hard coded as being in screen space. We could bind like the positions of these textures to buffer data that we feed in. But I don't think that's worth it. I think that like it just having one rectangle makes sense. So for now, I think I like the idea of maybe having like a tile something who like takes in the view state as well as the tile bounds and figures out where it should go in screen space. Yeah, that seems reasonable to me. That seems fine to me. So for now, we'll just kind of shove this in like app somewhere. I don't really give a shit. And we'll call this like lat tile to screen, tile lock screen space. Which is going to take in the whatever the fuck we have in satellite data. So kind of like this thing. So satellite data item, which means that our satellite data here needs to kind of import this. So this is satellite data lowercase to big case. This is lowercase. Okay. Long lat to screen space. Didn't I kind of already do that already? Kind of. I converted it to like meters space, which then the OpenGL shader converts to screen space, which isn't quite the same. So this is gonna do like metadata is this item metadata, and he's gonna take in the view state as well. And we have the code to do like this lat long to meters. So we do this to kind of unwrap it, I guess. Lat long to meters, which actually iterates over point data. So this is kind of not what we want. We kind of just want like not the for loop here. So I guess maybe we say lat long to meters doesn't take in the point data. He takes in a point, which is going to be 2 floats. We'll let it use a slice. I think that's fine. And then he returns back the point in meters space. Let me think about that. Sure. So this is going to be like 2 F32s, I guess. And then this is kind of going to be like, I guess kind of you want to own, like we're going to do this calculation one time and use it in all the others. So if we're going to reuse this, it actually turns into like a struct that's like lat long, like Coordinate space converter feels like what's going to make sense here, and we can say that the here we can like store width meters, height meters, and then we can also store like width degrees and height degrees. I guess maybe we don't need to store all 4 of these. Maybe we can store 2 plus a scalar for like one to the other, but or 2 scalars, I guess. In which case, why bother? Okay, so now we're gonna have a function here that's like lat lon 2 meters, which is gonna be kind of like. I guess here we need to store the lat step and the lon step. We use these a lot. Yeah, so lat step F32, lon step F32. Okay, that makes sense. Then we're gonna have like some initializer that returns our thing. And we're going to calculate this stuff. He's going to take in metadata initially, our like map metadata. And he's going to calculate like the width and the center of the map in latitude and longitude. He's going to calculate the latitude and longitude step and the width and height. This is width in degrees and height in degrees. No, this is meters. Yes. And then the width and height in degrees is just this part. Right, so const width deg is equal to this. Yeah. Yep. Okay. It's making sense. It's making sense. Height degrees is this. Yup. And then I guess we don't actually need to store the width and height in meters because we kind of have that based off of the step. Yeah, okay. We'll see where this goes. So let's just kind of take this stuff, kind of throw some dots in front of it, find equals, delete, back, wicked word, paste. I don't know, something like that. Okay. Then we have all the info, and then we just need to do this like actual conversion function. So it's just function lat 2 meters takes in a lat F32 and returns an F32, which is this. Here, I guess we need to store the maximum latitude. I guess we do need that. Self.mat lat step, sure. This needs self then. And I guess we just store a pointer to metadata. That probably makes more sense here. Probably makes more sense. So where is this used? Lat long to liter meters. He can just take in the metadata as a. Actually, I guess at this point we don't need it to be as a pointer. It's fine. But we will eventually. And let's just take metadata as a const metadata. Which means that we can easily calculate the other stuff later if we need it. I guess it doesn't make it. We're going to be calling this in a hot loop, so stashing what we can makes sense. So that's fine. Self, metadata, max lat, minus lat. Okay. This makes sense so far. And then we do lon to meters, which is very similar. This is a const. Let's see. Stash looks good for the stash for the window looks good. I don't know if you're talking about my mustache or because I'm stashing something in code. I can't remember what I said, but I'm gonna assume that you're complimenting my appearance and be like, "Thank you. What a nice guy this guy is." We can gaslight ourselves into thinking whatever we want. Okay, this takes in lawn. Like this. And there we go. Okay, so now we replace this with a coordinate space converter. Anime or no? Guys, what is going on today? Y'all are coming in and just saying, like, who cares? Like, we're writing code. We're making a map. What do you mean anime or no? What? It's irrelevant. Okay. This is going to be a coordinate space converter is a coordinate space converter initialized with our metadata. Then here, all of this stuff goes away. And this becomes lat is equal to converter lat to meters using our converter. And then here, we're going to do the same thing. Converter lawn to meters with lawn. Then this comes from converter width deg times converter. I guess here we can say that we want like width m, which takes in self-const coordinate space converter. Yeah, which returns self lawn step times self width degrees. And we have the same thing for height. This feels like it's making sense. Now, this is kind of split out in a way where we're going to be able to use this where we need it somewhere else, which is nice. Nice. Width m and height m. Okay. He's mad at 480 for some reason. Where? Appzig 480. What's he mad at? Oh, because I did just start writing a function and not finish it. So let's comment this out for a second. And we should make sure that nothing is like broken after we changed all that. So that does look correct still. Like all of the like closest road stuff is working. The map looks like it's the right shape. So looks like we're chilling. Okay. So now we can create that converter. So in map data, did we make this thing public? No, but we should. So here we'll just take all of these like functions here and publicize them. And now we can, yeah, we create this thing. So say const converter is equal to map data coordinate space converter in it with metadata, I guess, which I guess we're going to need to take in here. Sure. Then we are going to look at the item metadata center. Okay, we're going to do something with it. I guess we're going to convert that thing. So lat to meters, I guess. Sure. This is lawn to meters, I guess. So this is going to be the xm is this, and then we need this actually to be in screen space, which means what? I don't know yet. I don't know. So we're gonna look at like our view state center x is the center of the screen. So this is 0 in screen space. So we're going to do x meters minus this is going to be our distance in meters, probably times like the zoom level. I don't know if zoom goes up when we are more zoomed in. So the distance between points gets bigger the bigger the zoom level is. So multiplication makes sense here. And then we almost, oh, their zoom level is 2 over the width initially. Where else we use this? So this everything, when we go from normalized space, we do 2.0 over, but this is because this is 0 to 1. Which get movement. I think that this is in 0 to 1 space, not -1 to 1 space. So I think that we just multiply by zoom here. Or divide by zoom. If we're going from meters to screen space, I think we multiply by zoom. And then there's something we have to do with the aspect ratio as well. There's something to do with aspect ratio as well. So aspect ratio is width over height, I think. So I think for X, we don't use the aspect ratio at all, but for Y, we do. We only use this in the renderer, so we can check in vertex.glsl. We only use aspect on Y. So Y in screen space is aspect times zoom. And X is just multiplied by zoom. Yep, okay. So view state.aspect is how we do Y here. So const X S for X screen space and const Y S for Y screen space. So we're going to do the same thing. Okay, and then we do Y meters is converter lat to meters. And if we did all of this right, then we should be able to set a position for this thing. We won't worry about the scale yet. And if we set the position for this thing, then we should be able to see it kind of like stick to one point in the map as we wiggle it around. So I think this is a good initial test. So we'll call this screen space info. I don't know. Doesn't matter. I'll say fix me better name. I don't know. And he's just going to have center is a point, I think is what we called it. And then here we return center is equal to xs is equal to xs, or sorry, x is equal to xs and y is equal to ys. Okay. Yeah, maybe. So then whenever we call our render like our tile renderer, or our texture renderer, I guess, here we need to replace this center with const center s for screen space is equal to tile lock screen space comes from self satellite metadata. We know that we're using the 0th one. This is like a hack for now, but that's fine. Self view state and self metadata. And now we should be able to just call like center ss center or something. I don't know. Zig build, what's he complaining about? Sure, we'll dereference this, fine. It's fine by me. Screen space geometry, maybe? Yeah, that might make sense. WASM and run. Okay. So now if we did this right, it does look pretty tied to, oh, right, the zoom level doesn't change the size of the thing, but it does look pretty tied to like this correct location on the map. Which means that now we just have to fix the aspect ratio. We just have to fix the aspect ratio. So how do we do that? We just do more math. So how do they do it in our vertex shader? Our scale is just applied after. So we like put the thing at 0, then we multiply. Oh, we like subtract from the center. Okay. That's fine. So our scale is not related to the position, actually. Our scale is only related to the aspect ratio. And the zoom level, I think. So I think that we have like x scale is equal to, I guess we have like the size of screen in meters, right? We have our size of full map in meters times zoom is going to size of full map in meters times zoom is the something. This is something. Am I crazy for thinking this belongs to some shader mapping world to camera coordinates? So the only reason that we're not doing that is because the way that the tile is written, we are just kind of hard coding a rectangle that fills the screen. So there's like another option where we set the corners of the tile in meter space. And then you basically upload each tile like in one big vertex array and draw arrays for that tile. But the problem with that is we're not necessarily going to have all the tiles downloaded at once. So I kind of want the management of like level of detail and stuff to come from CPU side. Maybe that's fucking stupid, right? But I'm kind of thinking that like when I'm fully zoomed out, we're gonna know that we don't need all of the high res texture packs, right? And then when we zoom in, the CPU is gonna be like, oh shit, we need to fetch new pictures from our web server, right? And so that's kind of why I'm thinking it makes more sense to handle all this on CPU side, because like we on CPU already kind of need to do this mapping to figure out which tiles are in view, to figure out which ones that we need to fetch from the server. That's kind of why I went down this road. But I could see an argument that doesn't make sense. And then that way we don't have to like manage like the vertex buffers and like reshuffle them when we have different tile views and stuff, right? You could like maybe preset you could like look at the tile metadata and say like these are all the tiles that I will ever upload, right? And then you could like use like an element buffer and like just kind of like pick which indexes from that buffer you want. But I don't really see any reason, like we have to write the code somewhere. And so I don't see any problem with it being on CPU, especially because it's not like we're doing this for like thousands and thousands of vertices, right? We're doing this for like, maybe we're going to have like 16 tiles like ever on screen at once, right? So I just don't see like, I think it's fine this way. And it made more sense for me to do it this way, but I could see the argument. I can see the argument for something else. But anyways, I'll just say that there is a reason that it's happening this way, even if that reason is not necessarily the best reason. So, what is our width? What is our width? As the zoom goes up, width goes up. That makes sense. So zoom level when zoom is 1.0, we fill screen space. Zoom 1.0 is equal to full map width covers full window. Okay, so let's pretend zoom level is 1.0. Our width is going to be the item metadata size 0 over converter get width, right? Width m. This is the size relative to the width. Then we just multiply this by the zoom level. I'm not sure if this is 2 times as big as it's supposed to be. Because if this over this is going to be like 0 to 1, and screen space is -1 to 1, so we might have to like do some sort of like shuffling here. You will 100% find out really soon. Yeah, I think that instead of thinking, as is the tradition around here, we do not think, and we only just try stuff, because using your brain is for nerds. And then here, I'm not sure. Is it multiplied by aspect? I guess if it was over there, it must be for this as well. Part of me feels like these should be divides, but I can't really justify why I think that, so we'll start this way, and if it looks fucked, it will become obvious pretty quick. So this is x is equal to w, and y is equal to h. Okay, and then we call this this is center ss dot scale, which means that the name center ss is kind of fucking stupid. This should be like screen space something. Who fucking knows? If you aren't sure which way to do something, do it both ways and see which works better. Yeah, I'll take it. I'll take it. That is kind of how I see you're like Carmack. Yeah, it's perfect. I'm just like that guy. Okay, so it's just fucking gone, which is odd. Let's see what the fuck we did here. Any is screen space. What the fuck did we do? So scale is like infinitesimally small. As we zoom in, it gets bigger, but like way too small, low, like way too slow. Oh, because our center is in our size is in longitude and latitude. So we actually want to take our size and multiply it by converter. I guess we don't. We can work in land. Dude, my fucking mouth just fucking fell over. We can just work in degrees here. Because like the screen space relative to like our size over the size in degrees is going to be the same as our size in meters over the size of the screen in meters. So I think that actually kind of just works itself out. Okay. X is now, I mean, it's still quite small. As we zoom in, the numbers do get bigger, but again, they just feel like crazy small, and I don't really understand why. What happens if I just don't multiply it by anything? Okay, so that's kind of, so it's not changing size. That makes sense. So maybe we divide by the zoom? Part of me feels like that makes sense because, well, we'll see. No, that's fucking stupid. So we have our size. Okay, let's just think. Maybe we use our brains just a teeny weeny little bit. Whoever's asking about my distro, and then somebody posted Cave Troll Linux NixOS is in the bottom right. This is because when I was like 10, we built this computer, me and my dad, and maybe like a little older, but maybe like 15. Yeah, maybe like when I was like 15, we built this computer, and we were really into Lord of the Rings at the time, because don't forget that that's around when Lord of the Rings would have come out, right? And we had all of the computers in our house. We had tons of them because like my dad ran like some computer company, and we just like had a bunch around, and they were all different different Lord of the Rings characters. And since this was the most powerful computer in the entire house, we called it the Cave Troll, and that name is just stuck for my entire life. Isn't that kind of fun? So it just says Cave Troll, and it will always say Cave Troll. Okay, so how the fuck? I guess our zoom level is related to meter space, actually, because we just multiply the zoom in our vertex shader. We just multiply these like coordinates in, or like the positions of these things in meters by the zoom level. So the zoom level is the mapping of meter space to screen space, which means that for us, we need to go into meter space. We need to find the size of our object or like tile in meter space to multiply it by the zoom, or we divide the zoom by like our width in meters or something. So it's something like we do this times converter width m times the zoom level. That might be it. It looks like it might be actually divided by the zoom level. It looks like as I zoom in, it's getting... Oh, no, wait. Are the X bounds the same no matter what? The Y bounds are changing. But the X bounds are kind of staying... Right here is the corner of the tile. And that is staying consistent as I zoom. So I think we figured it out for X. Now for Y, it's again a little tricky here. I can't remember if we're scaling in height relative to width or height. Like, how do I say this? If we're trying to stay square, we might scale everything according to the width of the screen, which I think we do because we do zoom times aspect. So height m times view state dot zoom times view state dot aspect. I'm just kind of guessing here, but that feels like it would make sense. We will see though. So I'm going to kind of hold myself at the very top here. That feels kind of right to me. Now, this map does not match anything correct. Like, I don't know why we flipped the image, but I wonder if we weren't supposed to flip the image. I wonder if the image that we have is upside down. That seems possible. That seems possible. Let's try unflipping it. So we can go into where does this live? Fragment, image fragment, and we I guess it was in our rect.glsl. We flip it here. So here we just comment this out. Oh, hell yeah. Maybe? I don't know if this coastline really is matching anything that is sane. I'm gonna, like, if this is supposed to be the coastline up here, surface sand, I wonder if we can just try a different image, and that might help us understand a little better, just a little bit. So unfortunately, so I did like download a bunch more, but when I ran the make site script, it was not happy for some reason. The line in the water said footway. Yeah, I think that the footway was probably like trying to walk along the sand on the beach. But it could be something a little bit off. Did it have anything to do with the projections that you did a few streams back? Maybe the satellite images use a different standard of projection. Yeah, they might. That's definitely something worth considering. I'm gonna start by... I think that it's more likely that I've just fucked up my zoom level scaling a little bit. Like, I wouldn't be shocked if this is just 2 times too big. So let's like try to get more of the images. High res low tide, definitely possible. But there's something about like the fact that this thinks that there is a highway residential in here doesn't feel right to me. Right? It feels like these trees should kind of be like in this area, right? You could even maybe say that like this path here is supposed to be this path here. So I wonder what happens if we just like decrease, double the zoom level. Times 2? 2, this makes it fatter, so over 2. Let's just see what happens if we do that. The images can be a tad old. They're only like 2 years off, so it shouldn't be that bad. I mean, that looks more sane. I don't really know if there is a path in the trees here. It's really hard to tell. So I think that I want to try a different image for sure. So let's see. I tried to, so what I was saying a second ago was I tried to adjust, I tried to like run our like preprocessor script for a bunch more. So I got like 180 images. And it looks to me like this output is right? Like he has a bunch more paths in him. But then I think I saw that when I tried to run make site on this thing, it didn't work properly anymore. So let's try to look at that and see what the fuck is going on. There were like some like file not founds, and I'm not sure if they're like correct or not. But if they are, then we can just start like pulling other tiles and see how they look. We just gotta give it a sec. Give them a sec to think. Where did you get the image and path data from? Paths come from OpenStreetMaps. So I downloaded like using BB Bike, like an extract of some OpenStreetMap data. So if we look at here is an example. So this is like all of the like nodes, and then there's ways as well. So all the streets are like links between nodes that are tagged with like the highway attribute. And then the satellite data has come from Vancouver's Open Data. Ortho image here, this one. Open Data Portal. So it's just got orthographic images from 2022. For those of you who are tuning in now and haven't really been here for a lot of this, I've mentioned a couple times that the getting global high res street data kind of hard, but images is kind of hard, but per city you might be able to find like open data like this. So Burnaby has one as well. I couldn't find anything for North Vancouver, so we might have to fall back on like low res satellite imagery for that. But also, this is kind of more for like my debugging. So if we only have in Vancouver, it's not the end of the world because that's where I'm going to be using it. What was I doing? I was going to try to run make site and see why it's fucked. So make site, and let's run on the small data. So here he's complaining about like Vancouver preprocessed this not being there. So can we like ls this? And it is there. So why is it saying file not found? Oh, because he tries to delete a file. Oh, and it's just maybe the delete file like fails. That's just very possible. So we just kind of just had some like stupid fucking code in here. Catch here. Okay, let's try that. Does Google not provide an API for just the images? It's like really restrictive in its licensing, so I don't want to use it. I don't want to use it. Because it says that you're not allowed to cache them, and that you have like it has like usage restrictions. So after a certain amount of API calls, you have to pay, and you're not allowed to cache the data. So kind of just like fuck that shit, essentially. You know, like I'd rather just use data that I'm allowed to use and just not worry too much about it. I did this for a job a couple years back, and it's doable, but not mega easy using me wrong it. Wow, it's crazy. So what do you have any like insights for me as someone who's done this before? Like do you have insights for me that could help me do this better and or faster? That's because also like what were you working on, if you don't mind talking about it. If you don't want to talk about it, that's fine as well. I don't really give a shit. Like sorry, I don't give a shit. I'd be curious to know, but if you don't want to talk about it, you don't have to. Of course I can't make you talk about anything. You know what I fucking mean. You know what I mean. So I wanted to try just pulling a different image here from the link. So here, maybe we'll just put a concept here and we'll say like tile number is equal to 0. And here we have satellite data. Everywhere we're using this, we're going to use tile num, which it should just be here. And then we use it again on load of this thing. So we should now be able to replace tile num with like 5, and everything should just kind of work, and it should just put us somewhere else. Oh, okay, yeah, there it is. He's over here. Oh, hell yeah, baby. Wait, that's sick. Wait, that's so fucking sick. Look at that. Look at that. That's fucking awesome, man. What the fuck? Okay, I think that that's probably pretty fucking good. Oh, that's so fucking cool. It does look like maybe a little bit off, but I don't know if that's like from projection error or if there's just a little bit of error in like the OpenStreetMap data itself, right? Like, I don't know if this is supposed to look like this. But damn, that's fucking sick. It also doesn't have to be perfect, right? Because the whole point of this was that I wanted to just get like a little bit of like an overview of the city. That's pretty sick. Pretty sick. That's probably as close as you'll get. It's fine. Cool. I'm actually like really amped. Like, that's so fucking sick. Okay. Display it in the right place. Done. And now, we kind of have to figure out. Okay, well, I wonder how much memory. I guess each of these is taking up GPU memory, but not CPU memory. Because once it's loaded, um, we just like throw it at the GPU and then call it a day. So maybe what we can do is try to display more of them at once. Display more at once. We might limit it initially, but I don't want to like completely run out of RAM. But I suspect that it'll be fine because how big are these like uncompressed? What is like the resolution of these things? What is our resolution? It's like, let's just do some back of the napkin math before we go crazy here. So if it's a 1067 by 667, that's 700K times 4 for RGBA. So that's kind of like 2 megs per tile, hand wavy. And then if we have like 200 tiles, that's 500 megs on GPU memory. That's probably fine. That's probably fine to the point where I'm willing to try. Let's like maybe start small, right? We won't start with 5. We'll say num tiles. We'll start with like maybe like 10. Forgive repost. I was mapping ancient civilizations history using AST data. My buddy was the head dev at TomTom for the longest time. I can always phone a friend if you get stuck. That's pretty fucking sick. Does TomTom still exist? Like, I guess so. But in my mind, TomTom is like the era of like physical GPSs that you staple into your car, right? Like I remember seeing like in like maybe like 2005, like you would go to the Best Buy and you would buy a GPS and you would like suction it to your windshield. They were linking it to Bing last I heard. Okay, so I guess it kind of makes sense that like they had all of this tech that was related to like they had like all this like street map stuff and like path planning stuff, and I guess in the era of Google Maps and Bing, like you're saying, like they acquire these companies and just kind of yoink their engineers. Is that what you're saying, or are you saying that the TomTom is still like an independent company? That's pretty cool, though. Sorry, that's not even what you were saying. You were saying that you were working on ancient civilizations and history. That's pretty cool as well. Very cool. People are talking about sub licensing, so it sounds like they exist as their own entity, but they just kind of like sell their services to whoever needs them, which kind of makes sense. That's pretty cool. I kind of just assumed that those companies would have died. So it's kind of sick that they're still around. Okay, so our fetch data thing right now is like totally fucking broken in that if we try to fetch multiple things at once, we will just corrupt our data. So I think probably what makes sense here is we start by fetching tile index 0, right? And basically every time we load a tile, every time we get in here, we just ask again. And then we will only ever try to fetch one at a time. And here we will use how many tiles we fetched. So maybe we'll start here. Okay. We'll start with saying that we have like textures, more than one textures. And this is gonna be an array list of I32s. Whose, if we use unmanaged, then we can just kind of set him to his default value here. Okay. Then when we load a texture, we are going to say self textures dot append with this texture. Okay. That makes sense so far. We need to use self.alg as well. There, Indian, he was trying to get flying to US weekly meetings to get it done. Tired after flying 1 zillion miles. That makes sense. That makes sense. Okay. Now here, this is going to return an error because we can fail here, which means load, whoever calls load texture, which is going to be over here, is going to say catch stood log error, and then we'll log error data fetch error E, I guess, sure. And then this isn't E, this is any, and then we have to write E over here. And then I guess here we will still discard ID. That's fine because we can kind of implicitly figure out the ID by the texture length. Okay. Then we ask again. So GUI load data fetch data, and we're gonna use self textures items len. And where does the data come from? Texture or data ID is gonna be basically how many we have so far. So then we use data ID just everywhere here. All right. I love those Garmin's Yoda voice, man. Holy shit, dude. You just unlocked some memories. I forgot that they had voices. And I remember that like we would always fight about which voice we wanted on the GPS because we all had our favorites. That's so funny. I completely forgot about that. Okay. Cool. So this makes sense so far. On each time we load a texture, we try to get the next one. We do need to limit the amount that we're going to try to fetch. So if data ID is less than the number of tiles we said we were going to load, then we do this. Okay. I freaking love them. It was my job back then too. Yeah. Damn, dude. That's sick. Is there a good resource for learning memory management as someone who has only worked with high-level languages? Oh, dude, that's so hard. My path to this stuff was, I don't even know. It's been so long that I hate that like people ask me this. Like I don't hate that you ask me this. Like it's a reasonable question, right? But I hate that you ask me this and I can't give you a good answer because it's like if you were to ask me how do you learn English, and I'm like I don't fucking know. I just speak English, right? Like I don't remember how I learned it because it was so long ago. But yeah, people who are saying like learn C makes a lot of sense. This guy's saying, oh, dude, is this the famous PDF? Holy shit, dude. What I remember one of my first days at my first job, somebody sent me this and they were like, this guy who works here said you should read this. And then I read the whole thing and I never needed any of it. Was like what he said to me. And but this is a very good resource. This is like a fucking bomb. Now, if you're like, what do I need? This is a lot. This is very helpful to me. This is very good information. But like in terms of like if you're just like trying to write a program, it's not crazy. Somebody who just said write C doesn't seem crazy to me. Like if you're just like I want to like allocate an array, and you'll fucking figure it out pretty quick. Like you need the you'll fuck up enough using C just to the point where you'll need to figure out some level of basic memory management. Okay, when we call render, we now have to do this thing for everything. Could I do the same thing as Zig? Yep. Although, yeah, you could. I'm not gonna say that you shouldn't or should. Self textures items. And this is gonna be 4 now. And we probably want to do this like 0 ... I did a little bit of C in uni. I don't want to go back. C is pretty good, man. I'm not against it. But I can see the want to upgrade. Zig does feel like better C. It does. But C is pretty fucking sick. I don't know, like, if your reasons for not wanting to go back to C are that you have to do manual memory management, you might be in for a bit of a doozy. That was pretty sick. Do you guys see that? Bum, 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 bum. That's pretty fucking sick. Now, they're all loading the same fucking picture over and over again. So we're clearly doing something fucking stupid. And I think that it's in index Zig, we like get the image and then we have to clear it after. So this would be like requested data buff, clear retaining capacity. Probably makes sense here. Streamer so silence world, please. We will get there eventually, hopefully. Oh, hell yeah, baby. And the seams are working correctly. They're a little bit off, right? That's not perfect by far, which kind of indicates that there's some sort of like mapping bug going on. But it's definitely a good like V0. This kind of makes me wonder if I fuck something up or if there's like supposed to be overlap. The fact that the seams are not right here is concerning to me. Definitely. But you know what? As a V0, yeah, we also don't really know if the images are like supposed to line up perfectly. We don't really know. Are they perfect on the website? Yeah, I don't know if they show it on the website. Like I guess we could look at two adjacent ones and just try to like line them up with the file browser. So we could probably figure out that we're like looking at like here, this is kind of over here somewhere, right? Like so that's like maybe we're looking at like D16. Let's look at D17 and E17. D17 and E17. And XCG open E17. Let's just kind of see if we think these are supposed to line up. So we can kind of like we need to make sure that the zoom level on these is precisely the same. So we're going to kind of try to go up to 100 here. And then shrink it so that the corner of this thing is perfectly aligned. Okay, and then here we do the same thing. So get it up to 100 and shrink it down a little bit. And then line them up so that the top of the image perfectly lines up. So I think that these are supposed to line up. Now the question is do our, like how fucked are ours? So this was the shipyard and the one adjacent. Fuck, we don't have E17. We need more. We need more. From your website, you can tell it's a placement error. Yeah, I mean, if we assume that they're supposed to be tiled perfectly, which I think we can assume that now. I think that they are not correct. I think you're right. So the question is why? Because like the fact that it's close feels kind of weird to me. It could be floating. Whoever said floating point precision error at some point, that's not out of the question. We are using F32s all over the place, and those are like we do see real precision issues with those sometimes. And we're kind of like clipping, we're clipping the how do I say this? Like even like at parsing time from OpenStreetMaps data, we're immediately going into F32s. So it's very possible that we're just like fucked a little bit. Honestly, they're good enough for this purpose. I agree with that. I do agree, but I wanted to know like I do want to know if it's like really bad or just like a little bad. So let's try to like maybe just show more of them. I'm down. Well, let's actually first I want to see like does our memory usage explode? Because I don't want to have like a problem here. But it does look kind of fine. Okay, let's try adding some more. Fuck it. Fuck it. I did not do any transforms. I mean, I'm going from degrees to meters and stuff, and I am doing like a little bit of math on like there is like it's like not zero floating point math going on. There's like zoom level. There's like I didn't do any transform. Oh, I mean, like I didn't really like do any like projection stuff on the image. That's true. I kind of just assuming that they are unwrapped, but I didn't really check that anywhere. All right, let's try upping the number. Up the number, baby. Let's go like 100. Someone asked. That makes sense. And let's go into release mode. Just to get this shit moving. I should... So there's some prints here that I don't want. Log, debug, like... This probably is the one I don't want. All right. Dude, that's so satisfying to watch. Yeah, that's pretty fucking sick. That is pretty sick, man. I'm actually like so happy. That's so cool. Okay, let's just fucking unlimit it. So we'll say self satellite metadata len here is like the maximum. These things are projected flat surface where the base map might be assuming a curved surface. That's possible. I think the ortho projection fixes that. That's also what my initial guess was, but you know, we never know. It could like I don't really know what their expectations are. We would have to like double check the math here, but I mean this is totally fine, right? It's like there's like a little bit of error between them, but it could be that the error between them is kind of like making up for some like stupid behavior in our projection, right? Like that's very possible. Load all the images. I don't have them all. These are all the ones I have downloaded right now, so it's not perfect, but oh, that's so sick, man. I could show whoever said show Science World. I wish I could. But we don't have that tile. We could download that tile specifically. We can figure out where that is. We can figure out where it is. I guess I shouldn't be alt tabbing because the thing that I wanted was in fact this window. This is way better than anything I wrote for myself. That's fair. Yeah, I mean, we are going really far overboard here for like kind of no reason, other than it's fun. So Science World is a P10. P10. We can explicitly look for P10 here because I want to see Science World. You're right. Whoever said Science World, you're right. We do want to see it. So, maybe we JQ. I guess we'll go into test.py and we'll say if we'll look for the item name. Okay. If item name is not equal to P10, continue. That should do it. And then there's like this like fucking bullshit. Okay, we need to get into the right environment here. So one sec. Vancouver. How about it? Is it possible to auto download the images? I think that like I want to pre-process them in like a separate project because I don't want like my map project to be necessarily tied to Vancouver. I mean, it kind of is, but I kind of would like to do my best to keep it generic. So I've kind of structured it so that we kind of pre-process the images from somewhere else, then put them in like our data format, and then call it from there. So Steam run this thing, and hopefully we see P10 and only P10 downloaded here, which means that we can go back to our map. And we'll give him a sec. Give him a sec. He's got to extract this. He's got to like do this whole like Mr. Sid to PNG conversion, then he converts from PNG to JPEG. Oh, also the resolution of these things, we've like downscaled them by a lot intentionally, by the way, because like the source images are like fucking massive. So I think what I'll end up doing is like I'll probably end up making like a new project for every data set that I find, and then like make some way of like merging them together. But I think more likely is I'll only ever work with Vancouver. Okay, so you have to run make site again because it walks the output JSON. Ooh, hold on. Now I think that what happened here is that it will only have the output for the thing that it has. So here I'm just gonna say if not this exists, continue. That way it won't try to download anything new. And then we should get a proper dataset. Fuck. No, it's so hard. Cannot find zip file. That's fair. I don't care. If not zip path exists, Continue. I guess we'll kind of just throw these on all of them. For now. This is the way. There we go. Okay. So now we should be able to call make site, and it should hopefully get a science world in there. And if it doesn't, then we're going to give up because we need to move on and start trying to figure out how to make an LOD. But I do see P10 in there, which is a good sign for us. It's a great sign for us. Good sign for us indeed. I think it'll be the last thing that's loaded because it's the last in the list. We did it! We did it, and there's a circle around it. We did it, guys. Yeah, that's pretty sick. Pretty sick. Okay. Okay, that's enough. That's enough staring and liking. However cool it is. Well, do I really care about doing LOD support? Let me think about this for a second. There's a pretty good chance that I don't need it. Right? Like, if my GPU can handle all of the images loaded at once, then I don't need to. What's LOD? Yeah, so basically like as a level of detail. So in video games, like when you're like walking towards a tree and you see it turn from like four vertices into like a real tree, that's what they call those LODs, and it's like you get closer and you get like the higher resolution thing. But so the reason that I would do that is because it's expensive to load all of the images, right? But if they all fit on the GPU at once, and I'm only ever using satellite view for myself for like this, then it might be fine, right? Two Bob saying I could go down like 4x or 8x route, the most lazy LOD option. Yeah, I was probably gonna do like one Landsat image and then scale up to high res. But now that I'm thinking about it, I think that I just want to not do that right now, because I think that like increases complexity, and we don't need it yet. Will it work on your phone? That's a good point. Probably on my phone, but like on my phone, there's a good chance that I won't want there's a good chance that I won't want the images at all on my phone, right? Because it's kind of just like a waste of data if I know where I am, right? Like this is kind of like a nicety thing for me to be able to like quickly identify a location, but it's not like super fucked. I don't know. I'll think about it. I think that like I don't necessarily want to take that complexity on right now. And if we can handle just like, because like the next steps would have been, like we would have like some sort of like tile cache class, and that tile cache would load like the last like n tiles, right? And it would like unload textures as we like scroll around the screen, and it would maybe keep like the last like 50 loaded or something. And then as we zoom out, it would be like, oh, I want to keep that one. It's just like, it's a lot of stuff. And this is actually working like pretty good, like good enough, right? And you know, our mod around here is very often good enough. I could just turn off image by default when mobile slash detected. Yeah, or default it to off. Or when I go to production, not throw it in there. There's like all sorts of things that I could just not do to like just completely dodge the problem. So yeah, I think I call it there. I think that I'm like quite happy with this. This is pretty fucking cool. And yeah, I think more the next improvements would be a lot of extra code complexity that now that I'm looking at, I just don't feel like it's necessary right now. So what is your tab RAM, if you can check in Mozilla? Yeah, okay, let's look. Do I go into memory here and I just like take snapshot? 170 megabytes, right? Because the texture memory is completely GPU. So I wonder if I can look at like Radeon top or something. And this might give us like a better clue as like how much is, that's pretty normal. Yeah, I mean this is the 170 megs is all just like the point data on CPU. But here we're seeing, do we see like 3 gigs of VRAM? And if I close this, does that go away? Down to like 270, 2.7. So that's not even like that much. That was like maybe like, let's open it again. So that was 2.7 to 3.4 or 3.6. So like we're seeing like maybe like 800 megs of VRAM for this, like maybe we like triple it for how much we're going to see. So this will take up like 2.4 gigs of VRAM, which I'm fine with for now. Unless your phone is from the early 2000s, I'm pretty sure you can comfortably load all that on the GB memory, even on mobile. I'm not so sure about that. I think that once we get into like all of these things, we could maybe get away with like lowering resolution of these things even more, right? Like this level of detail is like not necessary. This is like 10%. We could go down to like 5 or even like 2% maybe, and it would still be fine. So, all right, cool. Unexpected, but fuck it, we'll call it there. So, early stream end for today. Thanks for watching, guys. If you like what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. This one was a little short, but yesterday was a little long, so it kind of balances out. If you're watching on YouTube, you are seeing the 2 to 4 segment, which we call the mainstream, and then there is happy hour beforehand where we work on like, code cleanup, making things, maybe small features that aren't really as necessary. We listen to music, we talk a little bit more, we're a little less focused. So if you want to check that out, those are archived on Patreon, or if you catch them live on Twitch, they are there. What's the next objective? Tomorrow we will probably be working on kind of more path planning selection. So like things like this is a busy street, and we can see that now. We can see that there's lots of cars here. So maybe I don't want to walk on busy streets. The complicated part here becomes this sidewalk here does not get tagged with that same busy street tag. So we're gonna have to do something intelligent there to somehow figure out how to correlate sidewalks with streets. So we'll figure that out, but that's the task for tomorrow. Did I plug everything? Like, subscribe, Twitch Prime. There's a Discord link in the Twitch description. There's a GitHub link in the Twitch description, where the code for this will eventually end up. Somebody asked, when will you release this? I think in chat, I don't really know if there will be a official release, but all of the code is available as we go, so you're free to do whatever you want with that. Okay, yeah. Thanks for watching, guys, and goodbye, YouTube. Twitch, let's find someone to raid.